Hey everyone, and welcome. Have you ever wondered how your bank keeps track of literally millions of transactions every single day without a single error? Or how an online store knows, down to the last item, exactly what's in stock? Well, today we're pulling back the curtain on the incredible, invisible system that powers pretty much everything we do in the digital world. Okay, so to get our heads around this, let's start with a really simple idea. On the left, you've got total chaos, right? A messy floor of toys. Good luck finding that one specific Lego piece. But on the right, you've got pure order, a perfectly organized toy cupboard where everything has its own special place. This simple difference is everything when we talk about data.
And that really brings us to the biggest question of all. We create quintillions of bytes of data every single day. So why isn't it all just one giant digital messy floor? How does anything stay organized? Well, the answer is a shockingly powerful idea that's actually over 50 years old.
At its very heart, a database is just that, a super organized cupboard, but for information. Instead of sorting toys, it's sorting names and numbers and all sorts of records. But the principle? It's exactly the same. It's a system built so you can find exactly what you're looking for the second you need it.
Okay, so let's translate that simple analogy into the more, professional definition. A database is a structured collection of data. That word structured is the absolute key to everything. It's that structure that gives us the efficiency, the speed, and the security to run our entire world, from your social media feed to the global financial system.
So how did this all even start? To really understand the why behind it, we need to jump in our time machine and meet the person who decided to bring some serious order to all that digital chaos.
You have to imagine what it was like before the 1970s. Storing data on a computer was kind of the Wild West. It was like having stacks and stacks of messy, disconnected notes. There was no standard way of doing things, no universal logic. It was just clunky and got incredibly difficult to manage as soon as things started to grow.
So the journey from this one brilliant idea to a global standard was pretty amazing. It all started in 1970 when a computer scientist at IBM named E.F. Codd published this groundbreaking paper. He proposed what he called a relational model for data. The idea was simple: organize everything into neat little tables with very strict rules. That idea sparked the creation of a language called SQL, and by the 1990s, Codd's revolutionary concept had completely taken over the world.
So how does this revolutionary idea actually work? What are the pieces that make it so logical and so powerful? Let's break down the surprisingly simple building blocks. Believe it or not, it all starts with something you already know very well: a table. Just picture a simple grid you might draw in a notebook, right? You make a column for your friends' names, another one for their age, and one for the city they live in. Simple.
Now, in the database world, we call this grid a table, or if you want to be formal, a relation. The really important rule here is that each table is designed to hold information about one single type of thing, what we call an entity. So you'd have one table just for students, a totally separate one just for products, and so on.
Okay, let's zoom in on a single line in that grid. One single row represents one specific thing. So in this example, this one row holds all the information we have about one student. His name is Amit, he's 10 years old, and he lives in Delhi.
The official term for this is a tuple, but honestly, let's just stick with row. The crucial takeaway is that each row is a complete, self-contained record for one single entry. It's not just a name or an age, it's the whole shebang for that one specific student.
Now, if you look down a column, you see a completely different type of organization. A column gathers up one specific piece of information for every single row in the table. So you have a column with only names and another with only ages.
The pros call this an attribute, and this is where those strict rules really start to shine. Every column has a name, but it also has a specific data type. The age column, for instance, can only accept numbers. You can't accidentally put a name where an age is supposed to go. This simple rule enforces that unbreakable order.
But hang on, what happens if you have two students named Amit, and they're both 10 years old? How do you tell them apart? Well, for that, you need a totally unique identifier, kind of like a student ID number that no two students can ever share. That unique identifier is called the primary key, and it has two non-negotiable rules. It can never be empty, and its value can never be repeated in that table. This is the ultimate guarantee that every single row in your table is 100% unique, no mix-ups allowed. Okay, so we've got our building blocks. But to make a system like this trustworthy enough to handle our most important information, like bank transactions, it has to follow a set of rock-solid guarantees. These are known as the 4 golden rules.
These rules are famously called the acid properties. First, A is for atomicity. Think about transferring money. The money has to come out of your account and go into the other one. If either part fails, the whole thing gets rolled back like it never happened. C is for consistency, meaning the database always follows its own rules. I is for isolation, which means lots of transactions can happen at the same time without tripping over each other. And finally, D is for durability. Once the database tells you a transaction is complete, that data is saved for good, even if the power goes out a second later.
Now, you might be thinking, this is all from 1970? In the tech world, that's practically ancient history. But here's the wild part. The relational model isn't just still relevant today. You could argue it's more important than it has ever been.
And here's why. SQL, the language we use to talk to these databases, is still a fundamental skill for almost anyone in tech. This structured way of thinking is the absolute foundation of modern data analytics. And most importantly, when you have systems that absolutely, positively cannot lose or corrupt data, that ACID guarantee is still the gold standard. It's unmatched.
And this isn't just theory. Just look at where these systems run our world. The vast majority of banking, e-commerce, and healthcare systems are all built on relational databases. Your bank balance, that order you just placed online, your medical records, they are all being managed by this same time-tested technology.
I think this quote just sums it up perfectly. Raw data, on its own, is like crude oil. It's valuable, sure, but it's also messy and not very useful in its raw state. Relational databases are the refineries. They process, structure, and purify that data into a reliable, powerful resource that actually fuels our modern world.
So, the next time you check your bank account, or buy something online, or book an appointment, just take a second to think about those elegant, 50-year-old rules of order working silently in the background. What part of your day is being powered by them? Thanks so much for watching.